Welcome back, ladies and gentlemen. We have two word problems before us dealing with rational equations. This is a continuation of a previous video. So let's check out this question. The speed of the current in the Puget Sound, which is an inlet around the state of Washington on the Pacific coast. The current is 5 miles per hour. A barge travels 26 miles with the current, returns 26 miles against the current. The total travel time was 10 2/3 hours, so 10 hours and 40 minutes. What is the speed of the barge in still water? So the first thing you should know, you may have learned in a previous math class, is this very general formula. Distance equals your rate times the time. So for instance, if your rate is 50 miles per hour, just making up numbers, and you travel for 6 hours, what's the distance you would travel? You would travel 300 miles. So a pretty basic formula here. Distance equals the rate you're going times how long you're going that rate. Well, for this question, we have the barge going this way, 26 miles. And we don't know how fast the barge is going on its own, but we do know that with the current, as it says right here, with the current, which is 5 miles per hour. So we don't know the speed of the barge in still water, but let's just call that R for the rate. So you have the rate of the barge plus 5 miles per hour. Times the time it takes, I'll just call that T subscript 1, the time it takes to go 26 miles. And then it's going to come back this way, and it has to go 26 miles back. And the equation we would have is now it's going the same rate, however it's going against the current, right here, against the current. So whatever rate it's going, it's losing 5 miles per hour. Being slowed down by the current. And the time it takes is, we'll just call that T2, the time it takes. So our question is, somehow we need to relate these equations and find the speed of the barge in still water. Well, notice we have this total travel time of 10 2/3 hours. So we would have the time it takes, well, let me say this first. We have these equations. The distance of 26 miles, that equals the rate, plus 5, times the time, the first time. And then coming back, we have 26 miles, and that equals the rate, minus 5, times the time to come back, which is 2. Those T's, those capital T's, are going to be different because it'll probably be faster with the current and it's slower without the current. So as I was saying before, we have this information about total time was 10 2/3 hours. So let's solve these equations, both of these. Let's isolate T. To isolate T, we could divide both sides by the quantity R plus 5. So that would give us 26 over R plus 5. That would be the first time, T1. And then the next one, we would get 26 divided by rate minus 5. And that would be T2. So now we have these solved for T. If the total travel time was 10 2/3 hours, that means if you take the first travel time plus the second travel time, that would equal 10 2/3 hours. And we have these expressions that we just wrote right here to say, well, T1 is 26 over R plus 5, and then T2 is 26 over R minus 5, and that equals 10 2/3. So this is the equation that we could use right here. This is the equation we could use to solve this question. I'm going to need a new page to do that. So let's see if we can manage that. Here we go. So we have this rational equation. We have variables in the denominators. So to solve, we multiply each fraction. This will be a good review what we were doing earlier in the lesson. We're going to multiply each fraction by the lowest common denominator. The lowest common denominator would be an r plus 5 and an r minus 5. So when we multiply each of those, when we multiply this first fraction, this r plus 5 is going to divide out with this r plus 5. And we'll be left with 26 times r minus 5. And when we take the second fraction, we're going to have r minus 5, and that will divide out with this r minus 5. And then we're left with plus 26 times r plus 5. And that equals, don't forget to multiply this lowest common denominator by the right side of the equation. And that gives us 10 2/3. I'm just going to write that as 32 thirds times r plus 5, r minus 5. And then from there, it's just a process of simplifying. We would have 26r minus 130 plus 26r plus 130 equals 32 thirds, which is 10 2/3, times r squared minus 25. Adding like terms on the left, we get a minus 130 plus 130. We get down to 52r equals 32 thirds r squared minus 32 thirds times 25 is 266.6 repeating. We have an r squared on the right and an r on the left, so we need to collect all the terms on one side, set it equal to 0. 0 equals 32 thirds r squared minus 52r minus 266.6 repeating. And from there, you could try, if you're desperate, you could try to complete the square or factor, but I would recommend using quadratic formula. When you use quadratic formula, your a, this is your a, your b is negative 52, and your c is negative 266.6. Using quadratic formula, I get two answers. I get r equals 8.013, or r equals negative 3.13. We're talking about a rate, how fast is the boat going in still water. So this would be our answer, and our units would be, it's a speed in miles per hour. So we get around 8 miles per hour. So that was the first one, good example of using rational equations to solve a word problem. And now let's look at the last word problem. This says Jimmy adds 65% fruit juice solution to 15, so 65%, to 15 milliliters, that's 10% fruit juice. How much of the 65% fruit juice, so there's my question, how much of that, must be added to the other drink to create a new punch that is 35% fruit juice? So it sounds like we have some kind of like fruit juice plus some kind of drink that has fruit juice in it, and we're going to get a new juice. So in general, that sounds like what's happening. You have two juices mixed together, and now you have a new juice. We don't know how much of this fruit juice, FJ, how much of that fruit juice we have. So let's let x equal the amount of fruit juice. So that first fruit juice, you have 65% times x. So, it's not 100% fruit juice. That other 35% might be water or something. Plus this other drink, and you're told that drink has 10% fruit juice, and it has 15 milliliters in that drink. Not a lot. And you want that to equal some new amount. That new amount would be 35% times the total that you've just added together. So notice we take x milliliters plus 15 milliliters, and that would give us the total milliliters. So you'd have x plus 15. So on this side we have our totals, our total amount of both drinks. And then at that point you can solve. From that point we would solve, and we would get 0.65x plus 1.5 equals 0.35x plus, I believe it is 5.25. Subtract this one from both sides, so that would be 0.3x. Subtract this one from both sides, that would be 3.75. So x equals, divide both sides by 0.3, and you get 12.5. This is the amount of milliliters that's in the original juice that Jimmy has, that you would need to add to the 10% to get to 35%. This wasn't explicitly a rational function, but you could have written the equation as 0.65x plus 10 times 0.15. That would be an expression for how much juice there is. And if you divide by that amount of juice, if you divide it by your total amount of juice that you have, then you want it to be 35%. Sorry, I ran out of space there. So it could be a rational expression, but I think it's easier, it makes more sense in my mind at least, to do it this way rather than with a rational expression. Thank you for watching this video, and I will see you next time.